All right, so we're going to be taking a look at names and volumes of pyramids. So let's take a look at the first figure. We're going to consider the formulas first, then we'll look at their names and then their formulas, and then take a look at some examples after that. Okay, so object solid number one, right here, this is a triangular pyramid. That's the name. And of course, the formula for the volume of our pyramids are 1/3 times the area of the base times the height of the pyramid. Okay, so in this particular case, let's go ahead and label it. Let's say that the base triangle is a right triangle. All right, so let's call this little b and this is little h. And then this height right here, the altitude of the triangular pyramid, is big H. So this is called a triangular pyramid because you name pyramids based on the shape of the base. So this is a triangular base, so that's why it's a triangular pyramid. All right, so the area of the base is going to be the area of a triangle, which is half base times height. So the volume is 1/3 the area of the base, which is half base times height. Remember, this is the height of the triangle multiplied by the altitude or height of the entire pyramid. All right, so if we simplify that, we get the formula for the volume of a pyramid. Triangular pyramid is 1/6 base times height of the triangle multiplied by height of the prism. Okay, next one. Look at the shape of the base. Let's put some more details here. Let's say this is 90, 90, 90. And then opposite sides are congruent. Alright, so this is a rectangle. So since the base of this pyramid is a rectangle, the name is going to be, this is going to be a rectangular pyramid. Okay, the volume following the same pattern is going to be a 1/3 base times height. The standard volume for pyramids, 1/3 area of base times height. Okay, so let's say that the dimensions of this of the base are as follows. This is the length and this is the width, and the altitude or height of our rectangular pyramid is h. So the volume is going to be the 1/3 area of the base, which is a rectangle, length times width, multiplied by the altitude or height of the entire pyramid, which is big H. And that simplifies into 1/3 LW big H. Okay, the next one, this one in particular, the base is a hexagon. Okay, so let's say we're just trying to write down the formula for a pyramid with the base, let's call it a polygonal pyramid. All right, so let me make some markings here. So we want to, let's just name this a regular polygonal pyramid. So this is a general formula that we can use for all pyramids that the base is a regular polygon. It could be a equilateral triangle, a square, a pentagon, regular hexagon, and it goes on and on. Alright, so what's the formula for the volume in that general case? Still following the same pattern, volume is equal to 1/3 area of the base times the height. Okay, and then this becomes 1/3 times the area of a polygon is 1/2 times the apothegm multiplied by the perimeter. Okay, so let's mark the apothegm here. So it's basically going from the center. Let's see the most convenient one to take it to. So if you go from the center to the midpoint of one of the sides, so right there, this segment right here, that's your apothegm A. All right, And then since it's a regular polygon, all the sides are the same, so we can call this S, S, S. There are going to be n number of S's around. Alrighty? And then the height of our regular polygonal pyramid is big H. So the area of the base is going to be 1/2 the apothegm A times the perimeter P of the base. Okay, the distance around the base, that's going to be the perimeter, multiplied by the height of the prism, or the altitude of the prism H. You can simplify this a little bit further. Just multiply it out. We have 1/6 of the apothegm times. Another way you can write the perimeter is the number of sides multiplied by the length of the sides. Alright? And then multiply that by the height of the entire pyramid. Alright? So there goes your formula right there. And then the last one that we're going to look at is this one right here. If you want to be technical, you can call this a circular pyramid, but it's normally called a cone, like an ice cream cone. That's the standard name. Alright, volume, same pattern, 1/3 area of the base times the height, the altitude or height of the pyramid. So when we make our substitution, we're going to have 1/3. The area of the base is a circle, right? So it's pi r squared, and then multiplied by big H. And then the final format, we can write this as 1/3 pi r squared times H. Okay, so there goes the formulas for your pyramids that we're going to be looking at in this particular presentation. So that's your radius right there. And of course, you have the altitude or height of your pyramid, big H. Okay? Alright, so let's go ahead and take a look at some examples. Alright, so the task for each problem is to name it and then find the volume. Alright? Okay, so let's look at the first one. The first one, what on earth is this? This is the name, it's a rectangular pyramid. So it's a rectangular pyramid. We know it's a rectangular pyramid because of the shape of the base. Alright? It's an equiangular parallelogram, so that automatically makes it a rectangle. Okay? Alright, so let's find the volume. Volume is 1/3 big B times H. In this particular case, it's a rectangle, so it's going to be 1/3 length times width times height, as we discussed earlier. So let's list everything that we know for this particular problem. So for this one, L is 4, W is 7, and the height or altitude is 6. So we just plug that into the formula, okay? So the volume is going to be 1/3 of L, which is 4 times 7 times 6, like that. And we can carry out a reduction. 3 goes here 1, 3 goes here 2, and then you multiply it out. 4 times 7 is 28 times 2, that's 56. Okay, so what we have is a volume. We multiply 3 lengths, so the unit is going to be meter cubed. Alrighty, let's take a look at the next example. Question number 2. We're going to start off by naming it. So for number 2, the name is so what's the base? This is one of our regular polygonal pyramids, right? Well, how many sides do we have? 1, 2, 3, 4, 5. So it's a polygon with 5 sides. A regular polygon with 5 sides. So this is a pentagonal prism. A regular pentagonal prism. So let's write this down. So pentagonal pyramid. Sorry. I keep mixing both names because they both P's. A pentagonal pyramid. Alright, so what's the volume for that? So volume is going to be 1/3 area of the base times height. Okay, and then the formula we came up with earlier is 1/3 apothem times the number of sides times the measure of the side times the height. That's what we want. All right, so let's go ahead and list it all out. The apothem A is 7.6. The line segment connecting the center of the regular polygon to the midpoint of a side. Number of sides of the base polygon is 5. Pentagons have 5 sides. 1, 2, 3, 4, 5. The measure of each side length. So this is apothem A. This is S. 11. The measure of each side length is 11. And then the height, altitude, is 11. Okay, this is H right here, the altitude of the pentagonal pyramid. So let's go ahead and plug everything in. We're going to have volume is equal to 1/3 times the apothem, 7.6, times the length of a side. No, times, so apothem times the number of sides, which is 5, times the length of a side, which is 11, times the altitude of the pyramid, which is also 11. Okay, so 3 doesn't go into any of these, so we can just multiply the top and then divide our answer by 3. So in your calculator, you could do 7.6 times 5 times 11 times 11. Okay, and then when you get an answer, you divide your answer by 3. Okay, so if you do that correctly to two decimal places, is going to be 766.33, and the unit of volume is length cube, right? So 76.33 meter cube, and that goes your answer. All right, let's take a look at question number 3. So for question 3, we have a cone. All right, so let's take a look at the, write down the name. This is a cone. Volume, standard 1/3 area of base times height. So this cone is lying on the side. Okay, so this is the base. The base is a circle, so it's gonna be 1/3 times the area of the base is a circle, so pi r square. 1/3 pi r square times big H. Okay. All right. So if we do this, let's list everything that we know here. So for this particular problem, the radius is going to be 6 divided by 2, which is 3, because this is the diameter, right? This is the diameter. So you're going to divide it by 2. And then the altitude or height of the cone, if we stand it up, is going to be 7. All right. So our volume is going to be 1/3 times pi times 3 square multiplied by 7. Okay. Okay, so let's see what we can do here. We can carry out a reduction. This is 3 times 3, which is 9, right? So 3 can take, so let's work it out. So we have the volume is going to be 1/3 times pi times 9 times 7. So 3 goes here 1, and 3 goes here 3. And then you just multiply 3 times 7, that's 21. Okay, so your volume is going to be 21 pi. The unit is miles cube. This is the exact answer. Or if you want to do the approximate answer, you plug that into your calculator to 2 decimal places. It's going to be 65.97 miles cube. So they're both exactly the same thing. Okay? All right, let's go ahead and box our answers. So that's number 1, number 2, and number 3 in its exact and approximate forms. Okay, let's take a look at problem number 4. So problem number 4, what's this called? Look at the shape of the base of this pyramid. It's a triangle. So the name is going to be a triangular pyramid. So triangular pyramid. Triangular pyramid. Alright, and then the formula for the volume. Standard 1/3 base, area of base times height. And then here we have 1/3, the area of the base is half BH times big H. And then remember we simplified this earlier into 1/6, little b, little h, big H. Alright, so in this particular triangle, little b is 6. If that's little b, then the height is the side perpendicular to it. So little b is 6. Little h is 8. And then big H, the altitude or height of the pyramid itself, is also 8. Bam, bam, bam. Okay. So now that we have everything, we're going to go ahead and find the volume. Alright, so let's go ahead and substitute and calculate what our volume is going to be. So our volume V is going to be 1/6 times the base times the height of the triangular base, which is a right triangle, 8, times the height of the pyramid or the altitude, which is also 8. Okay, we can cross reduce here, cancel, cancel, and then this is going to be 64. We're multiplying 3 lengths. The dimension of volume is length cubed, so it's feet cubed for question number 4. Okay, let's take a look at one more example. Number 5. What's the name of this solid right here? So we see that the base is a regular polygon. So it's going to be one of those regular polygonal pyramids. So let's see how many sides. 1, 2, 3, 4, 5, 6. 6 sides. Hexagon. So this is a hexagonal pyramid. Let's write down the name. It's a hexagonal pyramid. The base is a regular hexagon, which means that all sides are congruent. Alright, so the volume, standard 1/3 base, area of base times height. So if we just apply the formula that we talked about earlier, it's gonna be, so let me show you both of them, okay? You can either go 1/3 times the apothem times perimeter times height, or if you want to simplify it further all the way down, it's going to be 1/6 of the apothem times the number of sides times the length of the side times perpendicular height. Bam, bam, bam. Okay? So let's put it all together. We're going to have the volume. No, let's list what we have here first. So the apothem A is 5.2. The number of sides, how many sides do you have here? 1, 2, 6, because we already talked about it earlier, is a hexagon. So number of sides is 6. The length of each side is also 6. And then the altitude or the height of our pyramid is 11. Okay, so this is big H. This guy right here is little s. And then this guy right here is your apothem. Alright? Okay, so let's put it all together. The volume is going to be 1/6 times the apothem, 5.2 times the number of sides, 6 times the length of the side, 6 times the height or the altitude of the pyramid, which is 11. We can do some cancellation here. 6 goes here 1, 6 goes here 1. So now we just multiply all this out, and then we're going to have, the volume is going to be, you can just use your calculator to multiply it out, and then you get 343.2. 343.2, this is a volume. So the unit is going to be yard cube. Okay, So if you take a look at what we're multiplying, remember apothegm side and the altitude are the lengths. N is just a number. Okay, it's not an actual measure. So don't think we're multiplying 4 sides. We're multiplying 3 sides. Okay, so there goes the answer to question number 5.